So there are multiple properties of solving, and today I'm going over the multiplication and division properties of equality, which allow us to solve and, like do what we need to do, basically. So just as a review, so you have some context to what we're doing, basically, we're solving linear equations. And linear equations are always able to be written in the form ax plus b equals c. That doesn't mean that they're always in that form, but you can put them in that form. So you could have something like 2x plus 5x equals 10. And when you combine like terms, that gives us 7x equals 10. And this is in the form ax plus b equals c. Just the b part is equal to 0 because there's no number added on. The basic rule for determining whether something is linear or not is by looking at the exponents. So if you have variables and there are no exponents on the variables at all, then it's linear. When you don't see an exponent, we always assume it's a 1. So these are also called first degree equations because the assumed exponent is 1 if you don't see one. So I have here on the box some examples of linear equations. What matters is that the variable doesn't have an exponent. It doesn't actually matter what the variable is. So when we're solving linear equations, well, first off, translating, because when you have word problems, you often have to translate something from English into math. Anything that is a sentence is an equation. So if you have a complete sentence, that is a mathematical equation. And equations always have an equal sign. If there's no equal sign, it's incomplete. You cannot solve. So you can only solve if there is an equal sign. And that's what we call finding the value of the unknown variable. So if you're trying to find out what x is equal to, or basically what number that you can plug in for x that would make this equation true, that's what solving is. You're trying to get that variable by itself, and then there's a number on the other side. So this whole process of solving is where we use the properties of equality. So there are 4 properties of equality. There is addition and subtraction, and then there's multiplication and division. And we're going to be focusing on the multiplication and division properties of equality. So the multiplication property says if you have something a equals b, then a times c equals b times c. What this is saying is, like, if I have 4 equals 8 over 2. This is something that we know to be true because 8 over 2 reduces to 4. If I multiply both sides by some number, I still get something that's true. So if I multiplied them both by 2, then I would get 8 equals 16 over 2, and that's still true. So that's what the multiplication property is saying, is that you can multiply both sides of the equation by the same thing and it's still equal. So we just basically say we can multiply both sides of an equation by the same thing. Think of it as you've got like a balance going on, or like a seesaw. You've got it equal. So if you got the left side and the right side maybe on a seesaw, like the 2 people had the same weight, if you're going to multiply, like double the weight on the left, in order for it still to balance out, you have to also double it on the right in order for it to stay balanced. Then the division property is very similar, where you've got two things that are equal, and then you can divide both sides by the same thing. So it's basically you can multiply both sides of an equation by the same thing, and you can divide both sides of an equation by the same thing. So we can divide both sides of an equation by the same thing. But the thing is, we never divide by zero. Because if you divide by 0, you get undefined. So we can divide by anything except 0. And so this would be if you had two kids on a seesaw and it's balanced out perfectly, and then you maybe took one kid off and replaced it with someone that's half their weight. To make it balance, you have to half the weight on the other side as well. So these two properties are used to solve equations that are in the following forms, where you have a number times a variable equals another number, or if you have a variable divided by a number equals another number, because the whole key of solving is doing the opposite. So to solve, we do the opposite. So if you have something that's multiplied, you're going to divide. And if you have something that's divided, you're going to multiply, because that's how we undo what was done, is we do the opposite and then they basically cancel out. So on top here, I've got, again, the multiplication property to kind of show you what we do. And the division property is actually the same thing as the multiplication property, because dividing is the same as multiplying by the reciprocal. So these are essentially, even though they have different names, the multiplication and division properties, they're basically the same rule, because division is defined as multiplying by the reciprocal. So that's important to know, that if you're multiplying by a fraction, you're really dividing by what is in the denominator of that fraction, and you're multiplying by like what's on top of it. So, and because of this fact that we're going to be dividing both sides by something, we often write our answer as a fraction, because it doesn't always come out nicely. And so when we show our work by writing it as a fraction rather than using the division symbol. So the only time I ever write the division symbol is when I'm reducing fractions. If I'm solving, I never use the division symbol. I always write it as a fraction to indicate that I am dividing. And this is because if you do end up with a fraction as your answer, you can see it, because you've literally written it as a fraction, and then you can see that you need to reduce it. Okay. So what I've got here is the different forms that I was talking about where you use this property. So all of them on this page are in the form AX equals C. So the letters A and C, so the letters at the beginning of the alphabet, are always used to represent numbers. And then the letters at the end of the alphabet are generally used to represent variables. So when you see AX equals C, it's assumed that A and C are numbers and X is the variable. Now, when you actually have numbers in it, then it's very clear what the variable is, because it's the only thing that's not a number. But all of these are in that form where you have a number times a variable equals another number. It doesn't matter whether it's on the left side or the right side of the equation, because they're still equal. So just as long as you have something times variable equals something. So I'm going to start on the top left. We've got 6x equals 54. So 6x is assumed as 6 times x. So if you see a number next to a letter, it's assumed to be multiplication. So we don't normally write the multiplication symbol there, especially we don't want to write an x for multiplication, because then it gets very confusing. So we assume that it's multiplication if they're next to each other and there's no symbol in between them. So if you've got two things multiplied, then you divide to undo it, to basically get rid of it. Because our whole goal is to have your variable equals a number. And it doesn't matter if the variable is on the left or the right, but your goal is to have your variable equal a number. So with 6x equals 54, we want x on the left. We need to get rid of the 6. So the 6 is multiplied, so we're going to divide by 6 to get rid of it. So we indicate that by just writing it like a fraction here to show that we're dividing by 6. And then if you're looking at it, 6 over 6 is equal to 1. So that's how that disappears, because then we just have 1x, which just simplifies to x because it cancels out. And then on the right, we have 54 divided by 6. And so then you would take your calculator, see, does that come out to a whole number? And that comes out to 9. So that gives us our answer, x equals 9. So if I move to the top right, I've got 12 equals negative 3p. So in this part, the p is on the right, which is fine. It's totally fine. It doesn't matter whether the variable is on the left or the right, but we need to get rid of the negative 3 that's in front of there. And so that's still multiplication. There's no symbol between the 3 and the p, so that's multiplication. And so we need to divide to get rid of it. And if it's a negative, you're always going to divide by the negative. We divide by the whole thing. So if we see a negative 3, we need to divide by negative 3. So on the left, I have 12 divided by negative 3, which gives us negative 4. And then on the right, you see that negative 3 divided by negative 3 is 1. And that's the goal, is we want to have it divide and equal 1 so that all we're left with is the variable. And so we end up with our answer, negative 4 equals p. I like to box my answers there just so it's very clear what your final answer is. So if we move to the bottom left, I've got 2k equals 0. So I want to get k by itself, which means I need to get rid of the negative 2 that's in front. So again, we're going to be dividing. So I'm dividing both sides by negative 2. So the negative 2 divided by negative 2 is 1, so that cancels, and I'm left with k. And then 0 divided by negative 2 gives me 0. So it's really important to know you're dividing by 0 things. If 0 is on the top, your answer is 0. If 0 is on the bottom, then it's undefined. But 0 is on top, so our answer is 0. So it's totally okay to get an answer of 0 when you're solving. Then on the bottom right, we've got negative 5 equals 4z. So I need to get rid of the 4 because that's in front of the z, so I'm going to divide both sides by 4. And in this case, if you do negative 5 divided by 4, you get a decimal on your calculator. You get negative 1.25. So if you do it on your calculator and you get a decimal number, that tells you want to leave it in its fraction form. And so we're going to literally leave it as negative 5 over 4, what we're seeing there on the left. And then that's your answer. The 4 divided by 4 is 1, so that disappears. Now, for z's, I always write my z with a line in the middle. And I just do that so it doesn't look like a 2. Because if sometimes I write 2's like this, sometimes I write 2's like that, And if I wrote a Z, it could be very confusing. So I always do a Z with a line in the middle so that I don't get confused. I've seen a lot of people who get the wrong answer when they're solving because they misread their own handwriting, because they got confused with what number they wrote. So I recommend that you get in the habit of writing your Z's with a line in the middle, just so that it looks different from your 2's, because otherwise it could get very confusing. Other letters that are confusing is like some people write 1 like that, but then that could look like a 7. So I always write my 1 like this so I don't get confused between a 7 and a 1. Some people like to put a line in the middle of their 7s as well, and that's completely fine, just as long as you can tell the difference between them. So are there any questions on any of these 4 examples? Okay. And I'll move on to my next 4. So here I'm throwing in some decimals. Haven't gotten to the fractions yet. We're just throwing in some decimals. But I'm also throwing in variables without a number in front, because that can be confusing for some people. So these are all still in the same form. On the top left here, I've got 32 equals negative y. So if you see a negative sign like that and there's no number in front of it, we always assume it's a negative 1. So this is the same thing as 32 equals negative 1y. So we want a positive y. We don't want a negative y. We need to divide both sides by negative 1. And I do like to color code and write it in a different color like this, just so you can see the intermediate step. And so 32 divided by negative 1 is negative 32. And then negative 1 divided by negative 1 is a positive 1, so we're left with just y. Now, what's special about negative 1 is that we could have also multiplied both sides by negative 1 and gotten the same answer. And that's only true with negative 1. So what I could have done instead is, if I had this 32 equals negative 1y, I could have multiplied both sides by negative 1, and that's usually how I show that I'm multiplying. And we get the same answer, negative 32 equals y, because a negative 1 times a negative 1 is a positive 1. So you get the same answer. It's just a matter of how you write it, but most of the time we write it as dividing because it follows the same pattern as all of the ones that we did here, where you have a number in front and you divide. But you can also multiply, you get the same thing. So on the right here, I've got one with a decimal. We have 3.81 equals negative 0.03p. So it doesn't matter what number is in front of the variable. We're always going to, if it's right in front of it, it's multiplied, we're going to divide. So we're going to divide both sides by negative 0.03. And when you have a problem with decimals, it's okay to leave your answer in decimal form because you were given something with decimal form. So you don't have to worry about converting it to a fraction or anything like that and then doing the math. You can leave it in decimal form and just use your calculator to figure it out. So when I do 3.81 divided by negative 0.03, my calculator gives me negative 127. And then on the right, I have p. So in this case, it gave us a whole number, which is great. We don't have any decimals or anything like that. But Sometimes you get a decimal answer, and that's fine, as long as you started with a decimal answer. So it's like if you start with a decimal, you can leave it as a decimal. If you start with a whole number or a fraction, you leave it as a whole number or fraction. That's the general rule. So bottom left, I've got 5.82y equals negative 15.132. So there's only two of you guys live right now, but I'm going to pick on the two of you. Which number am I dividing by in this problem to solve the bottom left? Which of the two numbers do I need to divide by? You can just type it in the chat if you want, or speak out loud.
You're going to divide by the 5.82.
That's correct. So it's always the number in front of the y. I see a lot of people do the wrong number, so that's why I ask. Because people are like, oh, I need to divide, but then they don't actually divide by the wrong number. So we're dividing both sides by 5.82. And you want to be careful that you don't actually like subtract or add. I've seen people do that. So while you're getting used to it, sometimes I've seen people kind of turn the fraction bar into a division symbol to remind yourself that you're dividing there. So that's a good practice while you're dividing to kind of remind yourself that that's division. So I've got negative 15.132 divided by 5.82. So this gives us negative 2.6. So in this case, we leave it as a decimal because the original problem had a decimal in it, so we don't have to do any conversions. Yeah. Yolanda, you have a question?
Yeah, so when we're writing it out and we have to like take a picture of our work, is it okay if we use like the old division bar
symbol?
Yeah.
Yeah. Okay. Yeah, you can do that. That's completely fine. Kind of like how I did it here, like
the bracket is what I'm.
The bracket.
Yeah, it's kind of like an
like something like this.
L shape.
L shape. Oh, you mean like this?
Yeah.
I do not recommend doing that because you have to kind of squeeze it in what you have here. You have to kind of squeeze it in and it gets kind of messy. And then it starts to look like a square root symbol like I just drew. And we're going to do stuff with square roots. So it works fine when you're working with just like whole numbers and stuff. But once you get into algebra, we start doing things with square roots. And then the symbols start to look very close. So I do not recommend using that. Okay. You could either use this division symbol or you use it as a fraction. And that will just make it easier when we do stuff with very similar symbols. Are there other questions? Okay, so the one on the bottom right here, we have negative 41 equals negative x. So just like the top left, if you've got that negative in front of the variable, you assume it's a 1. So I usually don't actually rewrite it as a negative 1. I just automatically know that I'm going to divide both sides by negative 1. So I don't usually do the step to rewrite it first. But if you know that you're not very good with negatives, it's probably in your best interest to rewrite that as negative 1x, and then you can see that you're dividing both sides by negative 1. Amanda, I keep seeing you go off mute, but I haven't heard anything. So if you're trying to ask a question, it's not coming through.
Can you hear me? I wasn't
Yes.
going to ask a question. I was just unmuting it in case, I knew the answer, so I was getting ready to
Got it.
say
Got
the
it.
answer. That was it.
Okay. I didn't want to know, I wanted to make sure I wasn't missing a question or something like that.
No, sorry about that.
No problem.
I didn't know you could see every time I unmuted it. Sorry.
Yes.
All right.
It does. Yeah,
No
it gives me the power. I can also see people's internet connection. It tells me whether you've got good connection or poor. So I've got
okay.
nice
All right.
features
Well, no,
here.
I don't have any questions.
Okay. So let's move on to the fraction ones then, because I have a feeling that's where all the questions are going to be. So, because I know fractions are not everybody's favorite.
Yeah, definitely. Fractions are the one thing that gives me anxiety, I think. So.
See, I think fractions are easier than decimals. So like, I hate doing the ones with decimals, but I love doing the ones with fractions. I'm not sure why. Maybe it's just because it doesn't scare me anymore. It's really not that bad.
Well, I think the fractions are a little bit harder, but they're both, I struggled with both. So in the past, but fractions a little more, I think.
Yeah. Do you have a calculator that does fractions?
My phone does the scientific calculator.
Okay. I don't know if the phone scientific calculator can do fractions. I've got a separate one that does fractions. I'm going to briefly share my camera and attempt to hold it up to the camera. So this is the one that I use. It's not really there. Oh, there we go. So I gotta try not to move it. Okay. So right above the sign, this is my fraction button. And so if I want to put in a fraction like 1/2, doing this in reverse order, so I do that, and then it gives me 1/2, and it gives me the fraction, and then I push enter, and then it kind of turns it into fraction format.
And you're right, my phone doesn't have that, but honestly, I've just been working out the problems on paper. It works out better for me. I think I kind of retain the information a little bit better when I work out the problem that way. So I'm not too concerned with it not being on a calculator.
Okay. So I just wanted to give that option because a lot of people do freak out about having to do fractions, and it's like, you learn about fractions in week 1. Now that we're solving, if you want to rely on a calculator for the fraction part, that's completely okay. Because now that you've gone past that, now the focus is on the solving.
Okay, cool. Thank you.
Yes. So, okay, so I've got 2 examples here because when you work with fractions, it does take more steps to write than it would necessarily when you're working with whole numbers. So on the left, we have 3/8b equals -9. So we have 3/8 times b. So we're doing the opposite. We should be dividing by 3/8. But dividing by a fraction is the same as multiplying by the reciprocal. So this is where we actually use the multiplication property, where we multiply both sides by the reciprocal of the fraction. So this is how I write it. I use a different color just so it's clear that I'm multiplying both sides by the reciprocal. So we're flipping the fraction. We want to get rid of 3/8, so we multiply by 8/3. Because what that means is basically the 8s cancel and the 3s cancel, and you're left with just b. And then we've got this thing that we're doing fractions with, and if you've got a whole number, the whole number gets multiplied by the number on top, or we can try to reduce it first. And so that's what I usually try to do. I want to reduce it first, so I don't have to multiply large numbers. So I write my whole number over 1, so I have it as a fraction. And so this is actually a nice, follow-up from my video last week where I was doing multiplication of fractions. So I want to reduce the 9 and the 3 because those I can divide both by 3. So I usually kind of cross that out, divide it by 3, which gives me -3. And then when I divide 3 by 3, I get a 1. So that's just how I show my work, but you can show your work with the division symbol like I showed in last week's video. And so then we end up with B, and so we multiply straight across. We have -3 times 8, which is -24. And then 1 times 1, it's 1. So it's just -24 over 1. And you write your answer simplified as just the whole number, because any number over 1 is a whole number. So we end up with an answer of -24 here. So the problem on the right is similar, except that now we have like a fraction equals something with a fraction. And we want to get rid of the 3 over 10. So again, I'm going to multiply by the reciprocal. So I'm going to multiply both sides by 10 over 3. And so that basically cancels out the fraction on the right. And then on the left, I want to try to reduce this fraction. So if you're like me, you can, try to cancel everything all at once. Like I've got a 10 on top and a 5 on the bottom. I can divide those both by 2. 10 divided by 2 is 5. No, divide them both by 5. 10 divided by 5 is 2. 5 divided by 5 is 1. And then that would give us 2 times 2 equals 4. 3 times 1 is 3. And you end up with 4 over 3 equals W. But you can see how that kind of looks messy. Like if you were trying to follow your work here, like, it's fine when you're doing a quiz to kind of show your work like this. But if you're trying to take notes, you look at this and you might be like, what the heck happened? How did we get an answer of 4/3? Because it's kind of hard to see what exactly happened. There's all these things crossed out and everything like that.
I'll be honest with you. You lost me there. That lost me right there at the end.
Yes. So I'm showing how, that is not how you want to show your work. It's fine to do that on a quiz, but when you're like taking notes, that's not helpful. So when we're taking notes, starting out, I'm going to start by what I'm multiplying both sides by, which is the reciprocal 10 over 3. And I always do this in a different color so I can still see what the original problem was. Because if you do it in the same color, then you can't tell, well, what was the original problem and what did I do after that? So I do that in a different color. Then what I will do is basically recopy that left side with the fraction part and then have that equal to W because I just canceled out the fraction on the right. Because 3 over 10 times 10 over 3, those cancel out. And it's at this point that then I would try to simplify or reduce my fraction. So I'll grab a different color again. And so I've got a 10 on top, 5 on the bottom. I could divide those both by 5. So, I'll kind of write divided by 5 next to both of those. And then I'll do a new line. 10 divided by 5 is 2. So I have 2 over 3 over 2. And then 5 divided by 5 is 1 equals W. And then I multiply those fractions together. 2 times 2 is 4. 3 times 1 is 3. And then I get my answer. So you can find your answer basically in one step like I originally did, but it's not very good for learning from later on.
Yeah, when you struggle with fractions, that's the easiest way to get lost is doing that. And I've done that to myself trying to work a problem before, but
yeah, don't try to do too much. Yeah, if you do too much in one step, you get lost and then you can't use it later on. So you want to really try to do every step separate. And what's really important here is the fact that I'm moving vertically down. Each new step is underneath the previous step. And this is how we do math when we're solving. So, and we did this with the order of operations. Each line is underneath the one before it, because the one we read it from top to bottom. And so that it's showing us the logical steps. You go from top to bottom. If you start going top to bottom and then also going left to right, then it gets really confusing, because then it's really hard to figure out where you're going. And then also, because you have an equation, you have something on the left and something on the right. If you start going left to right, then you now have an equation with like 5 pieces, and it kind of gets confusing on where's the actual equation you're working on, because you end up having a lot of things like equal to each other. Because I've seen people.
So
go ahead.
Every step should be a new line under it then?
Yes.
Every single step, you know what I mean? Okay.
Yes. Every step when you're solving, make it a new line underneath the other one.
Okay.
Because I've seen people who we'll start with the same problem. They'll do the 10 over 3, 10 over 3, and then they do something like this, and then they like might write their answer. And then it's really confusing, because you're like, well, what is W equal to? Is W equal to this thing? Is it equal to this thing? Is it like, what is your actual answer?
Yeah.
Because they kind of do both sides at the same time. And I've seen a lot of people do that, and then they end up writing things that are equal that are not actually equal. And then that gives you something that's incorrect. So just always work top to bottom. Are there any questions? Okay, so I've got 2 more with fractions. Again, these are sort of in the same form, ax over c, although this one on the left is really sort of in the form of variable over a number equals a number, the alternate form that you could see it, except that it's also got a number on top, but it's kind of combined. So on the left, I've got negative 4z over 7 equals 1. So if you see the variable on top of a fraction and it's worked with numbers, this is the same thing if this was negative 4 over 7 and then the z is separate from it equals 1. Those are the same thing. So sometimes you'll be solving and you'll have a fraction and your variable is on the top of the fraction, but it's really treated differently. It's basically kind of in the middle. So it may look a little different, but it means the same thing. It's just written that way because we like to combine our fractions together whenever possible.
Okay, but so with it being written like that with the z kind of in the middle for both, you know, the 4 and the 7, I mean, couldn't that be confused that you would have to times the 7 by z or whatever, so you'd have 4z over 7z?
So I've
seen what I'm
people,
saying, how that
so I've seen that happen, and that is actually incorrectly multiplying a fraction by a whole number, because we're assuming z is a whole number here because we don't know otherwise. And whole numbers are always written over 1.
That's right. Okay. Right.
So yeah, so I've seen people do that and put the z on top and on the bottom, but what they're doing then is not actually following the rules when you're multiplying a fraction by something that's not a fraction. So whenever you have a fraction times something not a fraction, the not fraction part always goes on top. So that's just something that you're going to want to know, because you'll often see this in both forms, and you need to know what it means. You need to know that that z is on top, not on both. So we can do this problem multiple ways. So when it's in the form that we originally see with the z on top, what a lot of people do is first multiply by -7 to get rid of the denominator, and then divide by 4. And they basically do it in 2 steps. If you see it in the form underneath it, a lot of people will do it in 1 step, multiply by -7/4, because you're doing the reciprocal. So they'll get you the same answer no matter which way it's written. So I'm going to just kind of erase this for now, because I'm going to do it the way that's in 2 steps. And just note, I'm going to just put this over here to note that these are the same thing. It's just written a different way. So what I've seen, what a lot of people do when they have something with a fraction, the rule to get rid of a fraction is to multiply both sides by the denominator. So we could multiply, like, let's say, just both sides by 7. So when you multiply both sides by 7, that 7 cancels out with the 7 in the denominator. And we still have that negative sign. That doesn't go away. So we have a -4z, and then 1 times 7 is 7. So if you do it this way, you're kind of getting rid of the fractions, and you don't have to multiply by 7/4. You're multiplying by 7, and now you don't have a fraction anymore. Then at this point, now this looks like the type that we had at the very beginning, where we want to divide both sides by -4. So that will leave me with z equals, and then I end up with a -7/4. So if the negative is in the bottom, it's the same thing as if the negative is in the middle, or the same thing if the negative is on top. Those are all equivalent. So we still end up with a fraction for our answer, but we didn't really have to multiply both sides by a fraction. We multiplied by a whole number, and it kind of looks a little nicer for people who don't like fractions. Does that make sense?
Yeah, that did make sense.
Okay. So then on the example on the right here, which is my last example, we see that we have -3/7 equals -h. So, you know, if you just did a problem on the left, you'd be like, oh, let's multiply both sides by 7, get rid of that fraction. But we don't care that there's a fraction on the side away from the h. We only care about what's on the same side as the variable. So all I need to do here is to basically get rid of this negative in front of the h by dividing both sides by a -1. If you tried to multiply both sides by 7 because you're like, I've got a fraction, I want to get rid of it, so I'll just go ahead and do that. And so I use the dot to show the multiplication so it doesn't look like a variable. You end up with a -3 equals -7h. And now you've got to get rid of this -7 in front of the h. So if you divide both sides by that -7, you end up at +3/7 because the 2 negatives cancel, equals h. And you're kind of back to where you were at the very beginning. So you need to sort of pay attention to where the fraction is, because you don't want to just willy-nilly divide or like multiply both sides by the denominator to get rid of a fraction, because you may just undo what you did in order to solve. So what we really want to do here, as our goal is to focus what's in front of the h, which is the negative. So what we really want to do is divide both sides by a -1. So when you see that with a fraction, this is where it's actually probably easier to write it as multiply by -1, because then you see, you know, you're multiplying something by a fraction versus dividing a fraction by something. So the negative times the negative is positive. We just are basically changing signs. We get 3 over 7, and then a negative h times a negative 1 equals a positive h. So my general guideline here is that if you have a negative in front of your variable without a number, if you have a fraction in your equation, I would multiply both sides by negative 1, because it just is a lot easier when you're dealing with fractions. Otherwise, I would divide both sides by negative 1 like we did on the top left here, because we had a whole number, not a fraction. They do the same thing, it's just one is easier to do than the other, depending on what it looks like. So I'll go back. And then, like the example on the left here, if you've got your variable written on the top of a fraction, I think it's actually easier to first multiply both sides by the denominator so that you can get rid of the fraction, and then divide by the number in front of the fraction versus working with multiplying by the reciprocal. So these are just like little tricks or little tips on what might be easier that, you know, there's nothing wrong with doing another method or always dividing or always multiplying by the reciprocal. It's just sometimes one way makes more sense or is easier to understand than the other. So are there any questions?
No, I don't think I have any.
Yolanda, do you have anything?
Just why my kids are still up.
They're taking advantage of the fact that you're not watching them.
Yeah.
They're like, hey, Mom's not here.
Yeah, I'm still up. He comes down here. I'm like, oh, what are you doing still up? No, good though.
Well, this was the last example that I had. So hopefully this gives you at least a good basic form on using this property to solve. When we get into week 3, which is starting in a couple days, we're going to be using this rule at the same time, or not really at the same time, but we're going to be using more than one rule. We're going to be using the addition, subtraction, and the multiplication, division. And you're going to be doing basically more than one step. Like these are kind of 1 to 2 step problems, and we're going to be graduating into 3 or 4 step problems because you'll be combining the rules. So it's good to get a handle on the basic rules this week, so that way when you get to next week, it's not too bad.
You should have seen what she just did then. My high schooler is in the same class as I am. He's in algebra.
You guys can help each other out.
He's like, I'm not good at this stuff.
You know what I've had people do? I had someone else who had a high schooler that was taking the same class, and her high schooler was watching my videos instead of his teachers. So I mean, that's an option.
He doesn't do videos, so that's what I was telling him. I'm like, well, when I'm working, you should come down here and sit with me, and maybe you can learn more. I mean,
yeah, maybe my videos are more effective.